And we are back. And Vivek is going to tell us about their efforts to shift left in performance engineering.
Hello, everybody, and welcome to this talk about shift left performance engineering. My name is Vivek Koul. I'm an engineering manager with McGraw-Hill, and today I would like to share my experiences and views regarding shifting the performance engineering leftwards. I've been in this industry of software engineering for around 14 plus years. I wore multiple hats as a software developer, performance engineer, and lately in the last 4 years, I've been into engineering leadership with a focus on performance, scalability, and reliability. Outside of work, I love to play cricket and soccer, and I'm an avid traveler. So let's get started. I would like to start with sharing with you our performance engineering journey here at McGraw Hill. We've had a big shift towards digital learning starting 2016. So the move involved to shift from conventional textbooks to digital content, which could be served online to students and teachers, with a special emphasis on performance of our products. This did involve multiple steps. For example, we moved from monolith to microservices based architecture, moved from on prem to public cloud containers and orchestrators like Kubernetes and ECS. We put a lot of effort on embedding performance engineering into the continuous integration pipeline. So it took a lot of time, almost spent 1.5 years on making sure that we are embedding performance into our CI pipeline properly, measuring and improving the overall product and feature quality, scalability, and reliability. In the last 1 year, we've been trying to create a self-service platform for our developers so that they could execute performance tests uh, and review results. We also have been trying to shift left, where we want to improve the developer productivity and make sure that our performance testing suites and scripts are as close to the developer as possible. And one of the big reasons for this has been uh, to make sure performance is a part of our development culture and we take into consideration our customer experience and make sure that our customer has a performant customer experience. Now, I would like to speak about our steps and tooling which we've been trying to utilize within McGraw Hill for shifting left. Let's start with the first point. Shifting performance left is equal to performance engineering upstream. What I mean by this is we need to make sure that performance is as close as to developers as possible, or ways to measure performance have to be very, very close to developers, and developers have to be empowered to embed performance testing into their code. And this requires a top down approach. So we need to get the buy in from the engineering leaders and engineering leadership to have a common goal of shifting left, which is very important so that we don't have uh, friction or clashes in terms of implementing shift left. We also need to think about embedding performance and scale into the design as a consideration so that early on when teams are discussing about design, we make sure that there is ample consideration about performance and scale. We need to help the developers to make sure that they are able to execute these performance tests in dev environment, and that is where developer productivity comes into the picture. uh, because these days everybody is trying to challenge the cognitive abilities of developers, and there are a lot of new or additional responsibilities which developers have to take care of. It's very important for us to make developers life easy and present these solutions for performance testing or performance monitoring, which make it easy for developers to understand the performance of their code. And this does tie to customer empathy because for us to drive shift left successfully, we had to kind of focus on how good of a customer experience can we provide in terms of performance and reliability. Also, a very important point which we tried to implement as well is frequent hackathons and trainings so that the development team and the performance engineers gel up together well and they understand the importance of working together, and it also acts as a tool, as a catalyst to make sure that there's a right set of culture which empowers shift left. The next step is basically how do we do measurements of static and dynamic performance. For dynamic performance or runtime performance, we usually use APM tools and logging and distributed tracing. For static performance, we are more relying right now on code reviews and best practices. The next step, which we think is very important, is making sure that performance tests are to be written at the lowest level possible, as close to the developer as possible, and the test should be with fewer external dependencies. We also have to make sure that we embed SLAs, SLIs as a part of the test itself so that we get a quick feedback. And we're doing that using our self-service platform, which we'll know about in the next forthcoming slides. Once the performance tests are written, they can be executed from any environment with a controlled amount of concurrency. So this way, uh, if we have to do a quick test on dev or QA stage or QA, we can do that. It is kind of environment agnostic, and we try to make sure that it remains like that with proper data creation. And to implement all of this, we've tried to utilize a mixture of K6.io and JMeter for writing the tests and test suites. JMeter mostly deals with you can write the JMeter using Java, and K6.io is something which utilizes JavaScript, which is again gaining a lot of popularity within our organization. Developers and performance engineers are supposed to write the performance tests in the same repo where the service code is written. Hence, anybody can go and execute the test when needed. Tests can be executed locally as a part of the, could be on the local dev environment or the local laptop where a developer wants to run the test or PQE wants to run the test. Uh, and it can also be executed via PR and CI pipeline. The next step was basically to make sure that the written performance tests uh, will be executed a part of build with reliability. So this is where we've spent a lot of time in the last 1 year. So we are homegrown self-service platform to execute tests as part of CI. So we support integration with Jenkins, Circle CI, Jira, New Relic, and Slack. Uh, we try to devise pass-fail criteria right now based on response time, latency, and error rates. However, we are working closely to introduce some other new criteria which could be based on some development best practices. Let's say, for example, how many number of database calls are you making, or how many number of HTTP calls are you making for a page to load, whether or not your JavaScript is in the proper position on a page or not. So stuff like that is something which we want to incorporate as well. And last but not the least, tying our performance requirements to the user journey so that we could uh, take a deep dive into UI performance as well. Of late, we did not do a very great job in terms of UI performance. We were more kind of uh, engaged into API performance. So we started to embed UI performance as a part of Shift Left using Puppeteer and Lighthouse. So now I would like to talk about the performance self-service platform for Shift Left, which our team has developed in-house. It is using Java, Node.js, uh, HTML, and Angular as a front end, and we do have MySQL as a backend as our central repository. This platform helps us to execute tests using multiple testing tools, which we have mentioned earlier. It could be JMeter, it could be K6.io. Uh, we can actually execute tests on multiple CI platforms like Circle CI or Jenkins. and integrate all these results with Slack, Jira, and various other APM toolings which we are using. So, what kind of tests do developers execute using this platform? Right now, we are using single user API smoke tests, which could be part of daily build activity or could be part of your PRs. We are running tests which focus more on throughput than concurrency in the lower environments. Tests which usually would take less than 10 minutes to execute so that we don't choke the whole build pipeline because we have to make a decision based on pass and fail. Single user UI performance tests, uh, tests executed with pull request, post build validation of tests, and some tests like if you have to do a basic blueprint deployment validation on feature flags and you want to run some tests in production directly, uh, that's something which we are using this platform right now. Uh, and these all the tests on left hand side are primarily targeting our CI pipeline. There are tests which the platform runs which do not generally run on CI. So we have tests like endurance tests, capacity tests, which might be involving auto scaling, end-to-end UI performance tests with concurrency, again tests with API tests with high concurrency, and some of the chaos tests are also executed on this platform or using this platform, which are not part of our CI right now. So here you can see some more details about our self-service platform, uh, where we have a lot of customization available. We can actually trigger SLI, SLO based alerts after the test is executed. We can actually see response time trends. We can compare test across builds. If you see over here in the screenshot, you might find that there's a red color row at the bottom, which basically is red because you've reached the SLA, the 90 percentile SLA, and we've automatically raised a bug as well over here. So this is like I would say one of the features on our platform where you can automatically raise a bug uh, on test failures so that the individual teams get notified and we could get immediate feedback. Well, this is a bonus feature, and we have a system in our platform which actually monitors our production volumes or production throughput. And the reason we put it here is because a lot of times we find that uh, in order for us to run tests, we don't have throughputs readily available for developers and engineers. And we want to make sure that that's not a roadblock. So we basically run jobs in production every 1 hour to dump API throughput per hour for multiple of our apps, and then we expose those results via our platform so that if a developer or if a performance engineer wants to go and figure out, hey, what was the peak throughput of this particular API or what number should I use to kind of run a test, then this service can help them. And this way, it's also helped us to make sure that when the sprint planning is happening, we don't outrightly rely on the product team to get the volumes. We have our own system which can help us do that. Although for the new APIs, we do rely on the product teams to get us the volumes. But for most of the cases, if a developer wants to execute a performance test and doesn't know the volume or expectation, they can go to the system and get those volumes. So here I want to talk about some lessons learned during our shift left journey. Although I still feel that there are a lot of milestones yet to be covered, uh, but I just want to share what we learned in the last 1 year from our journey. So we want to make sure that performance testing is a shared responsibility by empowering developers to execute small scale performance tests. This is very important when you are shipping features every day and want to shift left. Have separate suites for API and UI testing in microservices because it's important for us to measure them separately. These are two separate tenets of performance. Uh, we have to have a clear performance pathway criteria for our CI pipeline. You need to make sure that you understand your SLIs and SLOs and uh, make sure that you're clear and you agree with everybody in terms of what numbers to use. If it's possible, try to figure out some production volumes for ease of developers and performance engineers so that they don't have to run from pillar to post to gather those numbers. And make sure that you run with an agenda which has developer and customer empathy. After all, uh, it's very important for us to make sure that developers get the best tooling and the customer gets the best experience. Thank you.
Thank you, Vivek, for sharing your experiences with shifting left. I'd like to remind everyone that they are welcome to ask their questions on the Slack channel. Currently, there are no questions. I'm going to go with mine, just a quick one because we are a little bit behind the time. So the question would be, how do you, so you mentioned that you have SLAs and SLIs and all is great, but how do you approach the gradual shift in performance? Because first of all, there is a lot of, like usually there is quite a bit of noise involved in measuring performance. And also when you have a gradual degradation of performance, which is not something that you can observe from just a single run. So how do you approach these challenges?
First of all, thank you, Taras. Thanks for having me here. It's been a pleasure for me to speak over here. Yeah, that's a very interesting question because there are a lot of times when you have fluke tests or you could have noise. For us, what we usually do is we keep track of the last 10, like 90 percentile values of a test run. So if there's a particular API, we would go and see what was the last 10 executions, 90 percentile response time. And if we see there's more than 15% of deviation, and then we kind of have an alert on that. So it's kind of a way for us. It works for us to just figure out, hey, why did this deviate? Why the deviation is like more than 15%? And if it's really some sort of a degradation, we go and rerun the test and try to figure out what could be the bottleneck. But this is our standard approach usually.
And so for noise, you just run a test, let's say 10 times, and then you use some sort of median or other statistics to decide whether it's this measurement is meaningful?
For our CI pipeline, we just run the test once. But since we have the older data, right? So we have historical data. We just do a comparison of that data. We compare our current results with those data.
Interesting. It's just usually there is quite a bit of variance because, for example, there is some noise happening, like some background jobs on the hardware, which can result in significant deviations. So,
right.
So in your experience, one run is enough?
No, one run is not enough. It's just that it's a periodic time, right? You build over and you see your SLIs, right? One run is just enough to pass the test, right? So if I have to pass my CI pipeline from dev stage to QA, right? We're talking about lower environments here. Usually these are isolated environments, single microservices which don't have any other background noise going on. So it's kind of a very, I would say, most of it is kind of a secure environment, which is not a production environment where you would see some external impacts happening. So for these are mostly targeted to small scale tests, right? So small tests which wherein you are running small microservices which don't have dependencies on any other system. So for tests where you have to do noise, introduce noise, we have certain other environments. In that case, we do kind of monitor that. In that case, one test is not enough. Actually, we do multiple tests for that scenario. This is more kind of the tooling which we have right now is more tied to small scale testing, which could be done in the development environment for the engineers. Right? We have some other environments to do big tests as well, where we could, we can have to monitor noise and we kind of don't rely on a single test.
Cool. Well, thank you so much, Vivek, again for sharing your lessons